Chapter 7 is going to be parity and proportions. We're going to be talking a lot in this chapter, like so much. It'd be great if we could read it. What is happening? There we go. Nope. Alright, so today, 7-1, we're going to just do our intro to ratios and proportions. Make sure that we remember those. Alright, those of you that took 7th grade math, a lot of 7th grade math was about ratios and proportions. So if you had like Miss Lukens, who's the other 7th grade math teacher at North? Miss Lukens, Mr. Ridpath was there with her. Trying to remember in your guys' day and age who else would have been there. Somebody else. And then over at Kennedy, I think it's Mr. Howfarth, I think. Yeah, I think. For 7th grade math, I'm pretty sure. Maybe not. Maybe I'm just crazy. Anyways, we talked a lot about ratios and proportions in 7th grade math, so it's been a while. So it's probably just a good refresher for all of us to talk about ratios and proportions. Okay? We do ratios a lot in math. Sometimes we don't always talk about it as a ratio. We don't name it. So anyone who learned slope last year, slope is what over what? Rise over run. You're comparing two numbers. You're saying for every time we rise this amount, we run this amount. So that's also a ratio, just sometimes you don't call it a ratio. Okay? So a ratio is a way to compare two or more numbers. Generally, ratios are only for two. That's what you've probably learned so far. Today we're going to compare three numbers with it. So we might say for every three stars, there are 5 circles. And we can draw that out. We have 3 stars. And we have 5 circles. There's a couple ways to write a ratio. This would be in words. For every blank, there are blank. That's a good way. Usually we say ratios. For every 3 questions on the test, it's 5 points. Things like that. For every 2 miles you drive, you use 1 gallon of gas. That's really bad gas mileage. Don't ever buy a car that says that. Ugh. All right. So, another way that we might see this is in an academic journal, we might say 3:5. 3:5. That might be a way that we see it. Generally, we don't write that in our work when we're showing our work. If you're going to write an academic journal that's going to be published in the special math magazines, you would probably write it with that 3:5. Okay? Another way that we would write it most of the ways that we are going to write it is as a fraction. 3 over 5. I'm going to kind of box that or do a little cloud around that one. That's generally how we write it. How we say it is 3 and then the word 2. So we're comparing from 3 to 5. And this is how we say it. We generally don't write 3 to 5. This is how we are going to write it. And this will be just how we see it sometimes. It's kind of an optional way to write it. Most of the time in this chapter, we're going to write it with that fraction. We just might see it in a problem with that colon. All right. Our other word today, we talked about ratios. What do you think is the other word we're going to talk about? Proportion. How did you know? Yeah, that's the title. Very exciting. All right, proportion. A proportion is 2 equal ratios. Alright, so for example, if we had 3/5, can somebody think of a fraction that would be equal to 3? We did it in our warm-up when we did 3 stars to 5 circles. We said now if Destiny draws 15 stars, how many circles did Destiny draw? 25. Why? Yeah, we thought like 3 times 5 is 15, so 5 times 5 is 25. That's one way to do it. Another way we might think of it is that we can make these into simplified fractions. If I do 15 divided by what? What can I divide both 15 and 25 by? Sorry. By 5. And 15 divided by 5 is 3. 25 divided by 5 is 5. So they end up being the same. 15 over 25 equals 3 over 5. If you look at it as simplifying fractions. So you could look at it as like multiplying forward. You could think of it as dividing top and bottom by something. Another way we can think about it is as a decimal. What is 3 divided by 5? Is 0.6. And if I do 15 divided by 25, 0.6. They're the same. So there's lots of ways to compare ratios to see if they're the same. You can think about them as simplified fractions. You can make them into decimals. Work your way out. All right, we have 4 examples that we are doing today. We're going to start with example number 1. Example number 1, we're going to ask ourselves, is it proportion? So if I compare 3 to 10, and I compare 4 to 1.5, I want to know, is that a proportion? So personally, the thing I'm going to do first is I'm going to translate those into fractions. So if I compare 3 to 10, what number goes in the numerator at the top? You want 3 or 10 in the denominator, in the numerator?
When we looked at our example, we said 3 over 5.
Usually goes in the numerator. We could switch it up if we really wanted to, but then we'd have to make sure we switch it up for the other one, and that's just a lot to remember. And we want to know, is 3/10 the same as what over what? You took our first number and put it in the numerator. So we want 4 over 1.5. And we want to know, are these two equal? In this first one, we have a smaller number divided by a bigger number. So when I take a small number divided by a big number, do I get a number bigger than 1 or less than 1? Yeah, smaller than 1. If I have like 2 candy bars and I've split between 5 people, not everyone gets a candy bar, right? But in this one, I'm taking a bigger number and dividing it by a smaller number. So if I have 4 candy bars and I have to split it into 1.5 groups, each group gets at least 1 candy bar. So that's going to be bigger than 1. So if you use that number sense, you should know that these aren't going to be equal, because this one will be less than 1, this one will be greater than 1. However, if that number sense, you're like, that didn't make sense. What is Miss Morel talking about? Cool. Guess what? Other ways to do it. I would just divide it. Throw it into Desmos. 3 divided by 10 is 0.3. Four divided by 1.5 is 2.666666666. So that's 6 repeating. We use that little line above the 6 to show it keeps going on and on and on. Are those numbers equal? No. And we'll put a little slash to that equal sign saying they're not equal. And my answer is no. Alright, we're going to do one more with this, with is it a proportion? I'm going to think, is 6/8 and 33/44. That's a weird fraction to say. 33 over 44, or 33 to 44. Are these the same fraction? Do they look like the same fraction? No, they don't look like the same fraction. Could we simplify the fractions? Yeah. With 6/8, what can we divide both 6 and 8 by? What goes both into 6 and 8? 2. 6 divided by 2 is 3. 8 divided by 2? 4. Okay. 33 over 44, is there something I could divide top and bottom by? 11. If I divide top and bottom by 11, 33 divided by 11 is 3. 44 divided by 11 is 4. Are they the same fraction? Yeah. So if you like fractions, if you're like, yep, that makes sense to me, great. If you looked at this and you're like, I hate fractions, I'm getting flashbacks, I'm going to have nightmares tonight about all the fractions coming to my birthday party and just ruining it. Okay, if that's you, that's okay. Guess what else we can do? Starts with the D, ends in divide. Divide! Amazing. Alright, so we can do 6 divided by 8. And we get 0.75. And then I can compare that to 33 divided by 44. Oops. And we get 0.75. Are they the same? Yep. So is it a proportion? Are they equal? Yep. Alright, we're going to do one word problem, and then we're going to just talk a little bit about some algebra problems that we're going to be working with as we go throughout this chapter. Okay. Number 2. Alright, in triangle EFG, the ratio of the measures of the angles is 5 to 12 to 13, and I'm using those colon to show that ratio. I want to know what are the measures of the angles. Alright, so let's just draw a triangle. Doesn't matter what the triangle looks like. It's not going to be the exact triangle that we're looking at, but let's just pretend we got one. We'll call it E, F, and G. Alright, one of them has a ratio of 5. The other one has a ratio of 12. And the other one has 13. Are those the angle measures? 5, 12, and 13 in a triangle? How do I know that those aren't the actual measures of the angles? Oh boy. Can't tell if we're all just tired or this class never talks. Period 4 is insane, you guys. What do we know about a triangle and the angles in a triangle? They have to add up to 180. Are 5 plus 12 plus 13, does that make 180? No. So what we can do is we can keep adding on. If I add another 5 here, another 12 here, another 13 here, that'd be 10, 24, 26. Is 10, 24, and 26, is that going to make 180? No. So what we end up doing here is we have to make sure that we're multiplying these all to keep the ratio the same, the proportion. We have to multiply them all by the same number. But we don't know that number right now. What do we use in math when we don't know the number?
We know it's a number, but we don't know what the number is.
Variable. So let's just use x, just to be boring. So I have 5x, 12x, and 13x. And we just said that we know when we add those angles together, the 5x, 12x, and 13x, all of those angles have to equal what? 90? 180, yeah. So now we can solve that equation. So we're going to start by combining like terms. We're going to put all of those x's together. So if I have 5x, 12x, and 13x, I want to combine all of those x's, 5, 12, and 13. And we get 30. So we have 30x equals 180. I want to get x by itself. So how could I undo that multiplying by 30? Divide. $180 divided by 30 is 6. So x equals 6. Now, is that what the question was asking us to find? No, what was the...
So we're going to use that x. So how would we find the measures? We're going to plug in 6 for the x. Is that right?
So we have 5x, 12x, and 13x is what we said our three angles were. And what are we putting in for the x? 6. So we're going to do 5 times 6, 12 times 6, and we'll do 13 times 6, yeah. All right, 5 times 6, 30. So our first one is 30, and it's an angle, so we're going to say 30 degrees. 12 times 6, 72 degrees. And 13 times 6. Oops. 78 degrees. All right, we have 2 more problems yet today. So, just gotta find that rhythm. All right, these last 2 we're going to talk a little bit about some algebra skills. Just reminding us back to that 7th grade math. If we didn't learn it in 7th grade, that's okay. We'll learn it now. We got it. All right, number 3 and 4, our directions are going to be to solve the equation. So when it says solve the equation, what does that usually mean we want our answer to look like? What does that word solve tell us to do? Yeah, find the answer. Find the yep. So when we have an equation, we have an unknown, and to find the answer, we want to know what is that unknown. So in number 3, we have 5 over 4 equals m over 3. And my goal is to get that m all by itself. So what's with that m? What's on the same side of that equal sign? 3. Good. And what are we doing with that 3 and that m? What operation are we using? Yeah, division. So if this is division, we have to think, how do I undo division? What is that? Inverse of divide. Multiply. So we're going to multiply both sides by 3.
So if we had n divided by 3 times 3, we have now undone that. So n is by itself on this side. But we still have to figure out that 5 divided by 4 times 3.
So 5 divided by 4, and then I'm going to go off to the side. Make sure that you do that in your Desmos, times 3. And we get 3.75. In this chapter, it's okay for us to get decimals. We're going to get decimals quite a bit, and we're going to be okay with that. Decimals are okay. All right, last one, number 4. Number 4, we have 7 over n minus 5 equals 6 over 9. So there's a couple big differences between number 4 and number 3. Can somebody name one of the differences? The denominator? Is that what you said? Yeah. Where is our variable located in this one? On the bottom. This one, our variable was on the top. So it's easy to get rid of that division, but this time, now what am I dividing by? I'm not dividing just by the number, I'm dividing by the variable. That makes it a little bit more complex. And what's with that variable? There's a 7 and a 5. So the first thing we want to do is we're going to flip everything over. And then that way our variable is in the numerator and we can deal with that a little bit easier. Some teachers might teach you how to multiply both sides by the variable, and that's fine. It works. But for the axis of ease, here's another way of doing it. Flip it over. So in that first fraction, I'm going to put the n minus 5 on top in the numerator. What's going to go on the bottom? 7. But if I flip one side over, what has to happen with the other side? It also has to flip. So instead of 6 over 9, we're going to write 9 over 6. All right, now that n is in the numerator, we can really focus in on solving that. Who would be like the best friend of the n? Who's hanging out with that n? The 5 is hanging out with the n, or the 7? The 5. They're hanging out on top together. It's like bunk beds. They're on top playing a game. I don't know. That was weird. So we're going to get rid of the 7 first. How do we undo a dividing by 7? Multiply by 7. Yeah, opposite of divide is multiply. So I'm going to do times 7 times 7. Now, sometimes in our brains, we look at this 7 and 7 and we're like, oh, we're doing that. We see a divide, and we're undoing the divide with multiply, so that gets rid of the 7 altogether. So we're left with n minus 5 equals, and I'm going to throw that into my calculator, 9 divided by 6 times 7. We get 10.5. Is it okay that we got a decimal? Yes, we're going to get decimals in this chapter. It's okay. We're going to breathe. It will be fine. Real life is in decimals. All right, and then, am I done with that equation yet? Yeah, I still need to get n by itself, and what is with that n? The minus 5. So I have to think, how do I undo a minus 5? Good. Opposite of subtract is add, or that inverse. Okay, you might be able to think of that in your head. 10.5 plus 5, or 10.5 plus 5. If that's hard for you, that's okay. You can use a calculator. And we get 15.5. All right, that is it for our notes today. There is a practice in Schoology. It's open.
The weeks there says 7-1. Remember, go ahead and use a whiteboard or something if you want to write out some of these steps.
We only have about 6 minutes, so if you're moving, move quick so you can get it open.